All right, we're on the back. Now, to do the first section, it says match each equation with the appropriate graph. Each graph may be used more than once. Now, I think it'd be helpful to find the slope because the slope tells us so much. Well, I'm going to kind of zoom in as best I can on these graphs because they're tiny, so this is going to be a little funny. Okay, that's how I can zoom in. Let's make this a little less fuzzy. Much better. Okay, remember to find the slope. Oh gosh, this is going to be interesting. Okay, slope is always rise over run. Let's see what we get when we do rise over run. So I'm going to go from this point to, let's see, this is a good point. That looks good. So to go from those 2 points, I went up 1 and then over 2. And notice I went up, so that's positive. To the right, that's positive. So the slope on A is 1/2. Beautiful. Okay, let's find the slope on B. I'm going to choose, this looks like a good point, and this looks like a good point. Okay, this time I went down 1 to the right 2. Since I went down, it's -1 over, and then right is +2. So that one's -1/2. And for C, let's see, what's a good point? Let's see, this is a good point right there. And I like this point. That's another good one. So I went up 2, so +2 over 1. So +2 over 1, which, remember, any number over 1 is that original number. So slope of 2 there. All right, now my not fancy way of zooming out. Let's see how I can do this. Okay, that looks okay. Let me check my focus. Ah, much better. Okay, well, now that we know our slopes, I bet you it will be much easier to match the graphs to their equations. So this one looks like it's in slope-intercept form. So we get y equals mx plus b. Ooh, plus. Helps if I know what I'm writing, y'all. Jeez. Okay. Y equals mx plus b. So m is our slope. We have a slope of 2. So which graph has a slope of 2? C is the only one with the graph of, slope of 2. So C matches that graph. Okay. 18, we have standard form. So remember, that's ax plus by equals c. And remember, when you don't have a number in front of a variable, that number is 1. Another important thing to remember, or you can look at the poster by your door, the slope when you're given standard form is -a over b. Well, we can see our a is 1, so -1 over b is 2. So ask yourself which graph has a slope of -1/2. That's graph B. Okay, on to the next one. Okay, we have a lovely long equation. This looks like point slope to me, so that's y minus y1 equals m times x minus x1. That means our slope is 1/2. Which means it must be A. I know it's off my screen, but if you look back, our slope for A was 1/2. And finally, 20. We're back to y equals mx plus b. So that means our slope must be -1/2. And graph B has a slope of -1/2. Moving on to the next set. Okay, before we can do number 21, that did not copy well. It's hard to see your axes. So look at where the arrows are and make that nice and dark. Make those axes dark. So got this. And I see here's my other arrows. Okay, that makes it a little better. Not a whole lot, but it's a little better. Also, they didn't label this. We're going to assume that each line is 1. So assume each line is 1. Okay, to find the inequality, let's first put it in slope-intercept form. So I'm going to say y equals, well, we need y equals mx plus b. That means we need to find a slope. To find the slope, we need 2 points. So let's find 2 good points. You know what? I like this one a lot. That's a good one. Where's another good one? Yeah, this looks like a good one. Okay, so that means I went up 1, 2, 3. And I went over 1, 2, 3, 4. So that means my slope is 3 over 4. So I've got y equals 3/4 x, and then plus b. Well, b is our y-intercept, so look at your y-axis. Ask yourself, where does it cross? Crosses at -1. Okay, fabulous. That gives me my line, but now I need my shading. Well, I'm going to guess that y is greater than. So this is my guess. I'm going to guess that y is greater than, not equal to, because it's dotted. So this is a question. I think so. To test it out, let's try 0, 0. That's definitely a shaded area. So we should get a true statement. So put 0 in for y. Put 0 in for x. Let's solve. To solve, we got to deal with our parentheses first. 3/4 times 0 is 0. Well, 0 minus 1, that's -1. So is that true? Is it true that 0 is less than, or sorry, 0 is greater than -1? Yeah, that's true. So we were correct. This is our equation. Fabulous. So y is greater than 3/4 x minus 1. On number 22. Okay. Let's see. We got y equals, again, we need to find slope. So let's see. Well, this looks like a good point. This looks like a good point. So I went down 1 to the right 1. So that means my slope here is -1 over 1. Well, that's the same as -1. So I got y equals -1x plus b. Well, our b is 0. So I don't even have to write that. I can erase that. So y equals -1x. Okay, that gives me the line. I need to deal with my shading. Notice my line is dotted, so it's got to be less than or greater than. Cannot be equal to. I'm going to guess that y is less than -1x. That's my guess. Ooh, I can't use 0, 0 as my test point because that's on the line. So let's use -1, -1. That's definitely in the shaded area. So put -1 for x and y. -1. So I just replaced y with -1, replaced x with -1. Let's see what that gives us. So to solve, we got to deal with our parentheses. -1 times -1 is +1. So is that true? Is -1 less than 1? Definitely. Negative numbers are always less than positive numbers. So we were correct. Ta-da! So our formula is y is less than -1x. On to the last one for this section. So 23. Again, we want y equals mx plus b, so let's find our m. Let's find 2 good points. Oh, I wish my eyes were better. Oh, I feel so old when I do this. Oh my gosh, I'm so old. Okay, this looks like a good point, and this looks like a good one. There we go. Whew. Okay, so we went down 2, down 2 to the right 1. So since we went down, it's -2 over 1. Well, that's the same as -2. So I've got y equals -2x. And our b, we want to look at the y-intercept, so where it crosses the y-axis. We got 0, -1, -2, -3 is where it crosses. Okay, I'm going to say, let's say our y is greater than -2x minus 3. And actually it could be equal to, because that's a solid line. So let's try this out. Let's see if y is greater than or equal to -2x minus 3. And to test our hypothesis, we can use 0, 0, because that's firmly in our shaded region. So replace y with 0, replace x with 0. And we need to solve. Okay, to solve, we got to deal with our parentheses first. -2 times 0 is 0. 0 minus 3 is -3. Alright, is this true? Is 0 greater than or equal to -3? Yep, that's true. So we were correct in our hypothesis. That is the correct answer. Woo! 2 more sections. We're almost at the end. This has been a very long video. Take a deep breath. Let it out. We'll get through this together. Okay, next question. Ooh, we're writing an inequality. Yay, let me zoom out. And by zoom out, I mean move my camera. And I think that's as good as I can get, y'all. Okay, Math Club selling pizza for $2 a slice, lemonade for $1 per bottle. They're raising money for a trip. They think the trip will cost at least $450. Ooh, that's an expensive trip. All right. Well, let's say that the number of slices they sell, slices of pizza, oh gosh, I'm getting hungry, is X. Let's say the bottles of lemonade they sell is Y. That means that the total money they spend, we need to see how, or not spend, sorry, how much money they sell. It's going to be $2 times the slices they sell. That'll tell us how much they make by selling pizza. We need to add that to how much they make by selling lemonade. So it's going to be $1 times however many lemonades they sell. So 1 times Y. And we need to compare that number, so I'm going to put something here. We need to compare that number to $450. Well, we want this number to be pretty big. We want to make lots of money, make that money. So we need this to be bigger than $450. Do you think it could be equal to? Yeah. I would say equal to is okay here. Ooh, I might go back and change that. Do I think equal to is okay here? Let me check my notes. Da, 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 da. Pardon me while I think. Yes, equal to is good here. Because they would break even, which isn't the greatest, but that's okay. You can break even. Let's look on to number 25. Okay, we have a florist. They want to make a bouquet with red roses and yellow roses. I love yellow roses. The vase that she chooses looks best with fewer than 25 flowers in it. Well, let's call our red roses X. Let's call our yellow roses Y. And we want a total of fewer than 25 flowers. So that means we just need to add X and Y. That'll give us a total number of flowers, X plus Y. We compare it to 25. Well, it says that it's got to be fewer than 25. So this number, our total number of flowers, needs to be less than 25. Do you think it could be equal to? Nah, it needs to be only fewer than, so not equal to. That's it. X plus Y, less than 25. Okay, yearbook company promises to give the junior class a picnic if they spend at most $28,000 on yearbooks and class rings. Each yearbook costs $35 and each class ring costs $140. I'm going to change this. This problem does not make sense because this yearbook company wants to make some money. So they want those juniors to spend at least, let's change that to at least $28,000. Yeah, spend that money. Okay, let's say yearbooks, our Y for yearbook, and I'm going to call the class rings X. So the total amount spent on class rings is going to be 140 times X. Total amount spent on yearbooks is 35 times Y, and we need to add those two amounts together. Okay, that's the total amount the junior class spends on yearbooks and class rings. We need to compare that to $28,000. Well, we want them to spend at least $28,000. That means this number needs to be bigger or equal to. If it's equal to it, we're good. We still get the picnic. Or it could be bigger. That's fine too. Hey, we're on the last two problems. Yay! Hey, we need to just explain these two transformations. So remember, when we're looking at linear transformations, ask yourself what's changing. Are we changing b, our y-intercept? Are we changing m? Or are we grouping a number with x? Those are the three things that could change. We could be changing b, changing m, or grouping a number with x. Let's look at 27. We're going from f of x to f of x plus 5. Well, should be pretty obvious. We grouped this number 5 with x. If we look back at our notes, we're going to have a horizontal shift when we group with x. So it's going to be horizontal, but it's going to be the opposite of what you expect. So normally when we think plus 5, we think to the right 5. So instead, we're going to go to the left. So that means left, and guess by how much? 5. So that's how it changes. It went to the left 5. Alright, this next one, we have f of x, and then we go to f of x minus 6. So, let's think of it this way. Let's say f of x equals x. Okay, then we switch to x minus 6. That's the change that's happening here. And a little reminder, if you have just x, that's the same as x plus 0. And hey, that's now in the format y equals mx plus b. So what do you think is changing? Do you think we're changing b? Are we changing m, our slope? Or are we grouping a number with x? Well, we're definitely not grouping a number with x, because this is not in the parentheses with x. Well, our slope on the originally was 1x. Here it's 1x. So it looks like b is changing. Look, our 0 is going to 6. So when we change b, that means we got a vertical slide, vertical translation. And it does exactly what we expect. So going from 0 to negative 6, we went negative 6. So that means we're going to go down 6. Yay! Gracias a Dios. We finished the review. If you have questions, send me a message. Email will be a great way to message me. Bye.